We are building the top trumps project from the YByte Python curriculum available at www.ybyte.in. In the previous video, we saw how we could take the choice from the player or from the computer and determine which is the key that the player wants or the computer wants, and what is the value corresponding to, let's say, this key for the player and the computer. Now, next step logically is to figure out who is the winner. We are going to write a function to do this. But before I get down to writing any code, I want to just spend some time trying to kind of give you a picture of what all this function needs to do. In fact, this function needs to be quite flexible because the winner or loser depends on which kind of metric is being passed. For example, let's take at the case of floors. Higher value is a winner because a building with a higher number of floors will be seen as a winner. But in case of year of construction, we are defining it differently. We are saying that, look, the lower value is the winner. So, if the building is, let's say, lower in the sense building was constructed earlier, that's the winner. So which means that, the winner depends on which key are we dealing with. Now, like I said, we can in fact classify this. For height, higher is the winner. For floors, higher is the winner. For year built, in fact, smaller is the winner. For built up area, again, larger is the winner. For time to build, again, shorter is the winner because, the building that was built quicker is considered, let's say, a winner here. Of course, these rules can be modified. These rules can be made more elaborate. Again, that goes into the, in the, let's say, area of bonus ideas and so on. But for now, we will stick with this. Now, what this means is that our function, if I were to take a look at, let's say, in a black box way, what does this function need to do? Well, this function will get two values. These are, let's say, the numerical values corresponding to what the player has chosen or the computer has chosen. Let's say, for example, height, or let's say years to build and so on. These two values are passed to this computer. Both these values, we will send this as floats because these are numbers and they may possibly have a decimal place. Floats are numbers with a decimal place. Hence, we say both of these will be floats. We will also give an input to this or an argument to this, let's say, function, which tells us, look, what is the rule to be followed? Higher is better or lower is better. And this function will create for us an outcome. The outcome will be simple. Three possibilities: either the player wins, or the computer wins, or there is a draw. Now, no matter what is the rule being followed, if the two values end up equal, then clearly there is a draw. So these are the three possibilities. Now, this situation is, a little bit reminiscent of what we had done, let's say, long back in the, in the memory game in Scratch, where we had this question whether if my node visited a particular building. Now, the answer to that could be yes, could be no. Depending on whether the building had been visited or not been visited. It's a little bit like this, but we'll see that now with the knowledge of dictionaries and with all the programming that we have learned, we'll do it in a much more concise manner rather than writing, let's say, a complicated if-else statement. How do we do this? Well, we will write this. How do we do this? Well, we will make use of dictionaries. So I'll just give you an idea of the code first, and then we'll start writing this code because that's what makes it more clear. We will create a dictionary inside this function. Now, this dictionary is interesting. The keys of this dictionary are player and computer because those are my two, let's say, characters in this game. The values for these dictionaries are what are coming from outside. So M1 and M2 are the values. Now, we will separate out the values and the key. So that's the V and the K. If M1 and M2 are equal, doesn't matter. That's a draw. On the other hand, if the order is 1, which means that we are looking for the, let's say, the max, we will pick out the value, which is the max. We'll find out where the value exists and read out the corresponding key from the other dict list. We'll see this working. It becomes more clear. And likewise, in the other case, we'll pick up the minimum. Now, we'll talk about this, why we have put order equals to 1 in just a moment. But first, let's get to the code and write this piece of code to see how this works. So I come back here to my code. Now, I'm just going to say, look, this function has to be outside clearly. So I'll just do it, let's say, just after my, let's say, the display cards function. So I just say function to determine a winner. Let's just say, well, def say determine say winner. Like I said, we'll pass three arguments, M1, M2. This is the value corresponding to the player and the computer. And we'll also pass an argument called order. Now, order is basically the rule. I will set it to, let's say, 1 for, and I will talk about this in just a moment. Why do I do this? What does it mean? Like I said, we will create a couple of, we'll create a dictionary over here right away. Remember, anything and everything that we do inside a function stays local to that function. So this dictionary is really local to the function. So I just go and create a dictionary. Player, key is player, value is, let's say, M1, and key is computer, and value for this is, let's say, M2. So this is a dictionary local to this function. Now remember, I want to get the keys of this and the values of this separately. We can do that quite, we have done this before. So I just make two lists. I say v is, let's say, list for, let's say, dct dot say values. Now this will convert all the values, basically in this case M1 and M2, and k is a list for both the keys. So it's kind of, simple actually. So I just go and say, let's say dct dot, let's say, keys. Now having done this, I ask myself a question. Well, look, if say M1 is equal to M2, then that's a certain draw. I can just return, for example, a draw. Right now this function returns a string. That's perfectly fine. So I return a draw. Else I ask myself a question. Well, if order is equal to 1, now order equals to 1 means larger is better. Let's say larger is the winner. How do I know who's larger? Is the player larger or is the computer larger? Well, I can do this quite concisely in a single command. I can just go and say, well, look, let's return. So read the key corresponding to the larger value. That's the whole idea. So I'm just saying, well, let's read the key where, v dot index, let's say max of v. Now very concise, but think through it carefully, making a lot of sense. What we are doing is we are finding out the maximum value of v. There's only two, so bigger of the two. We are finding out the item number of that, the index of that. So which of those values is bigger? That is my v dot index. Now remember, k and v are really in sync because they're coming from a dictionary. I can read the key for that index, and hence basically I'll end up returning the one which is bigger value. On the other hand, if order is not equal to 1, well, I will just return exactly this thing, but in a reversed order. When I do this, I will make it, let's say, min of v. Now this function is pretty cool actually, because it returns us a string and it's quite flexible. Let's see this working. I just ran something right now just to kind of get the code moving. Now this function is available to me. Let's look at it in multiple scenarios, right? So for example, here if I say determine winner, for instance, let's say 100, and so I'll give floats, for example, here 100.0 and say 20.0, and order is, let's say, 1. So if I give this as the inputs, basically I'm expecting the player to be declared a winner, because remember the metric corresponding to the player is bigger and my order is 1, which returns me the bigger metric, and answer is player. The same thing if I were to do with order of 0, it will turn out to be computer, because now it's looking for lower being better. And of course, if I were to do, let's say 100.0 and 100.0, well, the answer is a draw. So this concise function can do this for us. Think through this carefully. Now, before wrapping this up, let me give you a little bit more detailed view on how this thing is working. Let's just take two numbers. For example, say these are, let's say, 110 and 88, say number of floors. Now, what we are doing is that we are creating a dictionary, which is player 110, computer 88. V becomes 110 and 88. K becomes player and computer. Assume order is 1. Well, v dot index max of v is essentially v dot index 110, which is 0, because remember item number of 110 in this list v is indeed 0. And then I go and read k0, which is player. So that's exactly what I'm doing, and hence I return a player. On the other hand, I would have returned, for example, a computer. So I hope this made it clear. We will see how to use this in the game. We'll also spend some time understanding the default argument, which is the order, in the subsequent videos. I hope this has been interesting for you. In general, if you think this way of learning works, where we apply concepts, we build something interesting, and we learn programming that way, look at our website because we have many, many such activities. Take care. Thank you so much. Bye bye.